Our next unit is going to be on energy and different forms of energy. You can see in the picture here, these are all types of energy. So the windmills, the hydroelectric power, the solar panels, and just the sun itself can all be considered different forms of energy. Right now you need to have your L1 Nature of Energy sheet out in front of you. We're going to basically be going through the different types of energies and talking about how they change from one energy to the next in the video after this. Our first Roman numeral says, what is energy? And energy is any change that you observe, no matter how big or small, involves a change in energy. So you need to write energy in your first blank. So the definition of energy is the ability to cause change. And this is supposed to be an A right here. And I have two different types of examples for changes in energy. The first type that we have is glass shattering when a baseball hits it. So when a baseball hits a window, you basically have kinetic energy that's all stored in the baseball, and that energy is being transferred to the window, and it's actually what breaks the window apart and shatters that window. Now, our other example is combing your hair. In this example, the food or the energy that you've eaten for the day is actually going into moving your body and moving the comb through your hair. And for your first talking point, I'd like you to write down that no matter what, energy is always constant. So even if you're using energy to comb through your hair, the energy from your food is going into the energy of moving your arm. It's going into heat energy. The important thing is that it's not lost at all. So energy is always constant. Next, we're going to talk about the different forms of energy. And energy comes in many different forms. We're going to talk about 6 specifically. Usually when you guys think about energy, you think about how energy is produced, and usually you're thinking about electricity. So that's why we have the windmills, dams, solar panels, that kind of stuff is what we usually think about energy. But like I said, energy comes in many different forms. The first of these forms is chemical energy. And chemical energy is the energy stored in fuels or foods. So like the oranges here, the bananas here, and the apples here. The second form of energy that we're going to talk about is electrical energy. Electrical energy is energy transferred by the flow of electrons, and it's usually through machines. So that's why you see the refrigerator, the vacuum cleaner, the light, all these things use different types of electrical energy. You know, your phone, your headphones, all those things are electrical energy. The next type is thermal energy. Thermal energy is energy transferred through heat. So this is the energy, your body makes thermal energy. The sun gives off thermal energy. Stoves give off thermal energy. It's just any heat that you can feel. Next is light energy. Light is energy of electromagnetic radiation. So we're all comfortable with what light is. It's from the sun. It's from light bulbs. It's electrical energy can be used to produce light energy. It's just the energy of that electromagnetic radiation. Next, sound energy. This is energy from the vibrations of matter. So when you hear a sound, it's because all the molecules in the air are vibrating all the way to your ear, and you can hear that as a sound. The very last type of energy is called nuclear energy. This is probably the one that we're least familiar with. Nuclear energy is energy from nuclear fission or fusion. Now, for your second talking point, for 3 of the types of energy, I just like you to write an example of each, or how you use an example of each. one major type of energy is called kinetic energy, and this is Roman numeral 2. Kinetic energy is the energy of motion, such as a spinning bicycle wheel or a sprinter running. So that's this picture here. The guy's moving, so he has kinetic energy. Letter B says the more mass and the higher velocity, the more energy something has. So we can use a formula to describe kinetic energy. And C says that kinetic energy can be calculated using the following formula. And our formula for kinetic energy is Ke, that stands for kinetic energy, equals 1/2 mv squared. And this is where v is a velocity and m is a mass. Okay, so you can please write that down underneath letter C. All right, moving on to letter D. Letter D says the unit used to measure kinetic energy is called a joule. And we spell that Joule. The velocity is squared in the equation, Ke equals 1/2 mv squared. So when we double velocity, it actually quadruples kinetic energy. So basically what that's saying is that velocity matters more for kinetic energy than the mass does. So we have two examples here. If you remember from the last slide, we said that Ke equals 1/2 mv squared. And now we're actually going to use that equation to solve a couple problems. The first one says, what is the kinetic energy of a 250 kilogram motorcycle traveling 45 meters per second? So what we need to do here is we got to plug our values in. So we have kinetic energy equals 1/2 our mass, so that's 250. So we're going to write 1/2 250 kilograms. We're going to put parentheses around it. It means we're timesing. And it's 1/2 of mv squared, and our v is 45 meters per second. So we're going to write 45 ms squared. And then we're going to plug all that into our calculator. And the answer that we get is 253,125 joules. So that's a lot of energy that a motorcycle has. And that makes sense because the motorcycle is traveling very, very fast. Number 2, it says, what is the kinetic energy of a 2 kilogram baseball traveling 100 meters per second as it's hit by a bat? So once again here, we're going to do 1/2 the mass times the velocity squared. So we're going to have kinetic energy equals 1/2, and this time our mass is only 2 kilograms, and our velocity squared is 100 meters per second squared. So then we plug that into our calculator, and this time we're going to get 10,000 joules. Now that makes sense because a baseball is much, much smaller than a motorcycle, so even though it's hit very hard, it's going to have much less energy. Okay, next we're going to talk about something called potential energy. And what potential energy is, it's stored energy due to position is called potential energy. So in your first blank, please write this potential energy in right here. An apple hanging from a tree has potential energy because if it falls, its stored energy is converted to motion. So once it's whacked off the tree, it falls to the ground, so it must have had some sort of potential energy when it was hanging from the tree. Next blank says energy that is stored in a stretched or compressed object is called elastic potential energy. An example of this is when you stretch a rubber band or when you pull back a bow and arrow like this. So the ring or the bow is stretched, so it has elastic potential energy. Letter C says energy stored in chemical bonds is called chemical potential energy. This is like gasoline or food. So this person's filling up their car with gasoline. That's a type of chemical potential energy. Lastly, anything that can fall has stored gravitational potential energy. And this can be calculated using, so GPE, or gravitational potential energy, can be calculated by taking the mass of something hanging times 9.8, that's gravity, times the height that it's at. So here, once again, just like we did before, this is mass, this is height. So now we're going to do one example using this formula. So, pull this to the side. Our example says, what is the gravitational potential energy of a 2 kilogram picture that is hung 3 meters above the ground? So for this, we need to have that our GPE equals our mass, that's 2 kilograms, times 9.8 times our height. And the height here is 3 meters. So if we take 2 times 3, that's 6, times our 9.8, we're going to get about 58 joules. And we will have some more practice later in the week with gravitational potential energy. The next one says changing gravitational potential energy. Letter A says if 2 objects are at the same height, so like our book and a paperweight here, the one with more mass has more gravitational potential energy. So for your next talking point, I'd like you to write which one of these would have more gravitational potential energy. Now, it's the one that has more mass. Next, it says if 2 things have equal mass, the one that is higher has the greater gravitational potential energy. So in this case, the book on the top shelf would have the greater gravitational potential energy. So you should write higher in there. Letter C says falling objects. So when these things are, when they fall off the shelf, when that happens, they have gravitational potential energy and kinetic energy. So you should write that, this whole thing out there. They have gravitational potential energy and kinetic energy. And that's as they fall. So it says as they get closer to the ground, the kinetic energy goes up and the GPE goes down. So if I drop, let's say, the book here, as it's falling right now, it has gravitational and kinetic, still gravitational and kinetic, and then once it's about to hit the ground, it has basically all kinetic energy. And our very last slide is on temperature. Letter A says that all matter has molecules that vibrate. and move, giving them kinetic energy. When particles move faster, they have higher kinetic energy, and they feel warm. When they move slowly, they have low kinetic energy. And then it's when they feel cold. Letter C says that temperature is a measure of average kinetic energy. That's an R. Of atoms or molecules that make up something. The very last thing here, letter D, says that thermal energy is a measure of the kinetic and potential energies that an object has. That's going to conclude lesson 1 for our energy unit. Make sure that you have all of your talking points. During this video there were 3, so if you don't have 3 you should go back and check those. Thanks for listening.